We're going to do some buffer lecture, and then it'll become a work day where you can work on getting your pre-lab done for your buffer and work on sapling. And then next time we'll do the buffer lab. I won't be bringing your lab notebooks in again until I get back. Okay, so you'll have time to finish them up and get them pretty and do all that fun stuff with that. Test is open for this unit starting the 21st, which is Wednesday. Okay, and it'll be open until the next Wednesday at the 28th. Now, as soon as I feel better at home, I'll try and get your things that I can reach through Canvas onto Encore, but I won't promise anything until I'm back. Okay, so let's go ahead and let's talk about some buffers. I like this little thing I found. It said, police arrested 2 kids yesterday. One was drinking battery acid. The other was eating fireworks. They charged one and let the other one off, because the other one was dead. And the charged one, haha, fireworks. When you charge a firework, it goes off. Anyway, just a quick reminder here of what acids and bases are. You need to make sure you understand that acids are sour. They're a pH of 0 up to 7, not including 7. 7 is neutral. They have an AQ, and they'll usually be giving an H plus or a proton in a solution. Strong ones are considered 0 to 4 pH or below 0. Weak, 3 to 6. They're corrosive to metals. Remember, we talked about the different things that happen when they react with metals. Make sure you go over those reactions. They are proton donors and change red litmus paper to blue. Bases, on the other hand, are bitter. They're from 7, above 7, not including 7. 7 is still neutral. They're like soap. They're slippery. Strong is 10 to 14 or above 14, and weak is 8 to 10. They're in detergents, they're proton receivers, and they don't change the color of litmus paper if it's already blue, but if you got red litmus paper, it will turn it blue, and that's where we get their OHs. They're also proton acceptors. So this is just a real quick reminder of what's going on. Again, don't forget the test is available from the 21st to the 28th. I have put on the board your test dates while I'm going to be gone. You'll still need to be able to make sure that you go through those tests, even though I'm not here. They're still going to be open over at the testing center. Yes? You know, I'm not sure. They had spring break, but I don't think their summer schedule has started yet. So make sure you check, though. I would always check before I go up and make sure that you plan on a time that they're going to be open, because their spring ends before ours does, and their summer session starts, and so their hours are off. So make sure you're checking that out. We're going to be working with this KAs here in a second. We ended last time learning about the Henderson-Hasselbalch equation, and that's the equation that we're going to be using for our buffer lab. And so we need KAs, and they usually will either give you a chart like this, or they'll actually give you the KA in the problem. So I wanted you to show you the chart. You'll want to make sure that you go, if they're asking about KA, underneath the KA column, and don't put the KB, okay? Unless they're asking specifically about a KB. So we're going to work through this problem and work through a couple problems like this with buffers so we get this down. I've put the Henderson-Hasselbalch equation up here, and this is in your notes. We're going into notes, so if you haven't got your notes, you'll want to get them out, or at least a piece of paper so you can copy down some of the stuff that I'm doing today so that you can do it. Henderson-Hasselbalch lets us make buffers that are at a certain pH. We have to be able to work with what we've got. So for here, we're working with formic acid and its salt. We also have the Ka given to us, and we're going to make up a buffer solution. We need to know what the pH of the buffer solution is. So to do that, we have to find out first what the pKa is. Now, whenever something says P in front of Ka, POH, pH, we always minus the log of it. That's what the little p means. Okay, so we're going to actually take, and to get the pKa, we're going to go minus the log of 1.8 times 10 to the negative 4. And if you haven't got a calculator, you need to come get one because we are going to be using them like crazy today. So feel free to come get one or get yours out. The 1.8 was right here given to us. It's not given on yours, but I put it up here. You would have a chart or it would be given to you in the problem. Okay? All right, so somebody plug it through. What do we get for pKa here? 3.74. And it's just like POH or pH. You're going to report it to 2 after the decimal and be done. Okay? So now we've got our pKa, and we can look at it and say, okay, this is my acid because it says acid. This is my base because it's got a sodium in front of it, so that's going to be my base. I'm going to plug it into the equation. So pH equals the pKa. Whoops, let me erase that. We just did the pKa. 3.74 plus log of the base, which is a 6.5 molar, divided by the acid, which is a 3.0 molar. They're both the same unit, so they'll cancel out. And I put it through my calculator. What pH is this buffer going to hold at? .02? 4.08? It's a lovely 8 right there. Okay, and we're done. Okay, not too hard. Now, let's do a couple more. Here we've got another one. We've got sulfurous acid. So this is my acid up here. It's not going to write. I'm stuck. Okay, so let's see how you did. So first up, you would take and you want to do the pKa. So it's 1.2 times 10 to the minus 2. Whoops, forgot to put the minus log in front of it. Okay, so pKa here is what? Say it loud. 1.92. Okay, now at this point I'm going to say, okay, here is my acid, right? Here is my base, and I'm going to plug it in. So pH equals 1.92 plus log of the base, 0.46, divided by the acid, 0.52, close the parentheses. What pH am I going to hold at for this one? One 1.87. And I'm done. So if I've got how much base or what the concentration of the base is, what concentration of the acid is, I know what pH is going to hold at. But, yes. This is the Henderson-Hasselbalch equation, yes. And I always, since you guys can write it down on your 3x5 card, I would write it down on a 3x5 card because when I get in a testing situation, I always forget which is first, the acid or the base, top or bottom. And I always get that messed up. So if I have it written down, it saves me. So did you put minus the log parentheses 1.2 times 10 to the negative second power? Yes. This is what the buffer will hold at. So we have several buffers in our body that will hold our pH right about 7. So it doesn't matter how much acid I put in or base I put in, as long as I don't break the buffer, it'll hold it at 7. It's sort of our way to keep that at that pH. No, this is what it would hold. This buffer that I made would hold that pH at 1.87 until I broke it. Okay? All right, so let's go forward. Here's another one. This time, though, look at this one. I want it to stay at a pH of 7. So now I've got to build this buffer a little bit different. I don't know how much of each one I need, the acid, the base. I want to find out what the ratio is. How much more acid or how much more base do I need to add to make this buffer hold at 7? Okay, so I still am going to look at the Ka. I'm still going to find the pKa. So I'm still going to go minus the log of 4.2 times 10 to the minus 7 and find out what that pKa is. So let's do that. Somebody got an answer there for me? 6.38. Okay, we all agree? All right. So now I'm going to put the equation together, but I'm not going to have this. This is going to be my big X that I'm solving for. And when I get that X, I'll be able to find out what the ratio is. So putting in, I'm going to have 7.00 is equal to 6.38 plus log of some amount, X, some ratio. I'm trying to figure out what that is. So we're going to subtract 6.38 from both sides, right? Over here, it goes away. Over here, I'm left with 0.62, right? 0.62 is equal to log of X. Is everybody okay so far? Okay, now how do I get rid of log? 10 to the power. So I'm going to put 10 to the power of this on this side, 10 to the log of X on this side. Log and 10 to the X cancel out. They're opposite each other. So in my calculator, I put 10 to 0.62. What do I get when I do that? Say it loud. 4.2, give me one more. 4.20, okay, X. That's going to be my ratio. So what basically that says is I'm going to have 4.2 times as much base in concentration as I do for every one acid. So that's my ratio that I need to set up. So if I have a molar of 1 molar acid, I'm going to have a 4.2 molar of the base to make that pH stay at 7. Okay, does that make sense? So I'm solving for that ratio. All right, so what we're going to do now is I'm actually going to have 9 of you come up and do parts of these 3. So I'm going to have one of you come up on each of these, and I'm going to number them because we had a little issue last period about which one is which. We're going to call this 1, 2, and this one 3. I'm going to have the first person just right underneath over here on the right what the Ka is. I'm going to have another person right here set up the Henderson-Hasselbalch. Okay, remember the acid is going to be the one that has more hydrogen. Acid is the one that has more hydrogen. Okay, so you're going to set up the Henderson-Hasselbalch, and then I'm going to have a third person come up and give me what the new pH is. Okay, you ready for this? Okay, start working for a second. I'm going to give you a second to work, and then I'm going to just pull names out of a hat. Okay, here we go. Chris, I want you to go up and put the pKa for number 1 up. Kaylee, I want you to put the pKa for number 2 up. Larissa, I want you to put the pKa for number 3 up. Connor, I want you to put the equation up for number 1. Ethan, I want you to put the equation up for number 2. Cameron, I want you to put the equation up for number 3. Bryn, I want you to put the pH up for number 1. Alyssa, I would like you to put the pH up for number 2. And Andrea, the pH up for number 3.
That right? Like, is that how I do it?
So you get the pKa, just minus the log of that.
So, if I include on this one, when they solve for the pK, I just put that into there and do plus log and then the acid on the bottom.
Okay. Yep.
So I did 1.5 over 0.5, is that right?
Mm-hmm.
And so then I'd get that right.
Mm-hmm.
Hopefully that's right.
Hopefully that's right, yep. So the rest of you keep doing it while they're putting them up, and let's see how good they did. Because of course we don't want to just trust their answer, we want to make sure their answer is correct.
Someone did what I was supposed to do.
Uh-oh. See if there's something else that is at that area that you can do then. They probably did the wrong thing.
Are we supposed to run out the... I'm just going to wait for everyone else to finish and then I'll write whatever's missing.
Okay, sounds good. You don't know what you're doing yet. Yay! Thank you. Yes. Okay, let's look at these and see how we did. Okay, you didn't put yours up. Okay, hurry quick. pH on number 2.
Hey, can you check what I got? Or I think it's on the paper. 7.16, right? Yeah. Sorry.
Nope, you're fine. Okay, so let's look at these. Let's go over them. Okay, one thing I'm going to point out is whenever you write pH, because a lot of you have done this wrong, is it's not written like that. It's lowercase p, high, or capital H. Lowercase p means negative log. It's sort of like when we write a symbol on the periodic table, you have to write it a certain way. Same thing here. So anytime you write pH, POH, pKa, the P small, the others are big. Okay? All right, so did we get that for this pH? Okay, one thing they did wrong. What was it? They went to 3 after, so it should have actually been 5.22. Okay, just remember 2 after the decimal and you're good. Okay, what about number 2, the pH? Is that what we got for number 2? Oh, we got a no, no, no. Okay, what is the issue? What did we get? 6.99. Okay, so we need to double check that one and make sure that we put it in correctly. Is it set up correctly? It is set up correctly. So this is not the correct answer, but 6.99 is. Okay, what about number 3? 10.93. Is that what we got? 10.93 for number 3. 10.88. And that's lovely there. So I'll put it over here. 10.88. Does everybody agree with 10.88? Yes? Okay. So we need to do some checking here. Redo it. Is it set up correctly?
I think for the pH equation, it's supposed to be 10.32 instead of 10.37.
Ah, right there, 10.32, because it is 10.32 down here. Good catch. Okay, so just a little number can throw it off a little bit, so make sure you're being careful with your numbers. Everybody feel like they understand how to do this, plugging in. Okay, I hope that little exercise of you guys coming up and how do you do this helped rather than me just going through each one. Okay, let's go through another one real fast. Right here. This is in your pre-lab. I want to go through your pre-lab because it's sort of like what we've been doing, but it is a little bit different because we've actually got to weigh out an amount of the base. We've got to figure out how much base are we going to weigh out. Okay, so they have given you the Ka in the problem, and that's usually what they'll do is in the problem they'll give you the Ka or the pKa. They've also given you how much of the acid that you're going to be using. They have given you the pH. So, looking at those, what would be your first step? And for me, this little teeny bit amount of space is not very much to write all this. So I actually would probably cut that when I put it in my lab notebook and wrote it nice and neat, you know, big. But however you want to write it, that's fine. Okay, so what would your first step be? Find the pKa. So then I would go, okay, pKa is equal to minus the log, because I always want to show them what I'm doing, times 10 to the minus 5. So pKa is equal to what? 4.74. Okay, the next part, I've got my acid right here. This is my acid. But this time they gave me how much of the acid they got plus the concentration. They didn't just give me the concentration. So because in the Henderson-Hasselbalch, we have pH is equal to pKa plus the log of the base over the acid, and it was molarity over molarity, the liters cancel out. And I'm trying to find out how much to weigh out, so I don't want to have the liters in there, right? Because the liters would cancel out. So what I want to do is I want to take this down here, and I'm going to change colors here, right here, and I want to just take that 100 milliliters and change it into liters and times it by the concentration, 0.1 moles per liter, right? That's what molarity is, moles per liter. So then I can go through and say, okay, milliliters cancel, liters cancel, liters cancel, and I'm left with moles. So how many moles do I have? Okay. Is that how many I have? Yes. Okay, that's moles of my acid, right? So that's going to go right there. What am I trying to find? I'm trying to find moles of my base because then I can turn it into grams. So I'm plugging in everything I know. Okay, I want a pH of 4. So plugging into Henderson-Hasselbalch. pH of 4, my pKa is 4.74 plus log of, I don't know, divided by 0.01. Yeah, this looks fun, right? So then I subtract 4.74 from each side. Over here it cancels. Over here it leaves me with negative 0.74 is equal to the log of x divided by 0.01. How did I get rid of logs? Okay, take both sides to the power of 10. So power of 10 to this, power of 10 to this. Over here, log cancels with power of 10. And so I'm just going to write it over here real quick. I've got, what is 10 to the negative 0.74? 0.18? 0.18 is equal to x divided by 0.01. So then I'm just going to times that by 0.01, and my x is equal to 0.0018. Is that right? Did I do my math right? Okay, and that's moles of the base, right? What's the base? Sodium acetate, NaC2H3O2. So I'm going to need to add up how many grams are in a mole of that. And then I can take the grams times the moles, and I've got how much I need to weigh out. Okay, so I'm not going to finish it up for you, but you're going to have to figure out how many grams this is, and then times it by the 0.0018. Okay? You're going to do that for the next one. It looks like it's the exact same, buffer B, but it's not. So be careful about where the decimals are, okay, and do the calculations for buffer B. Now, when we come back to do this in lab next time, you would normally have to do 4 titrations with 4 graphs. But what I'm going to do is I'm going to group you in groups of 4 and have each of you do one of those titrations and do the graph and share it with everybody else in the group, so that we can do it quickly and efficiently and hopefully be able to work through. So having said that, we've got a little off on the side here. So there might be 2 groups of 3, and one of those groups of 3 is going to do buffer A, both the acid and the base. Okay, so when we do this buffer lab, we're actually going to be titrating buffer A with acid and seeing how much it can hold of acid, with base, seeing how much it can hold of base. Then we'll do buffer B, how much of acid can it hold before it breaks, how much of base can it hold before it breaks. And you'll get a graph of each of those. Now you're still going to have to do all the calculations of all the graphs to find out. So you'll need to do the, what was it called, that you had to find that perfect 7 point, or the point of inflection? The equivalence point. Okay, so, but what was that button we pushed on the computer so we could get that point of equivalence? Interpolate. So we need to make sure we put point protectors on and interpolate. I noticed on a lot of the lab that were turned in, they forgot those 2 things and I took points off. You also need to make sure that you can see your pH in the data table, because if you can't see the pH in the data table is worthless, right? So you need to be able to see that. Just a couple of things. So the rest of the time today is yours. Once you get your pre-lab done, come up and get it stamped. And then when we get ready for lab next time, I'm going to assign you what one you're doing. We'll make the buffers A and B as a group, because you only need 5 milliliters of the buffer for your whole titration. And it has you make 100 milliliters of buffer, and we don't need that much. Okay? Any questions? So the rest of the time's for sapling, for whatever you need to get done in this class, so you're on top of things while I'm here. So questions on pre-test, whatever. We'll do the buffer next time. Monday, we'll start the new unit, which is nuclear. We'll also be doing a cloud chamber lab that day because it's the last day I'll be here before I'm gone. Okay? Questions? All right, time's yours.